And we're back live today from the Living Free in Tennessee studio. I got my hair all up in a bun because I was just rowing. Because I got to do my 75 hard, which is two
You do your
workouts a
full, what
day,
is it, 45 minutes?
two 45-minute workouts. Yeah.
Nice.
So I find if I get my second workout before 5, my whole day is better because then I'm not like at 9 o'clock at night doing something.
Do
I've
you
only
do
had to
your
do that.
morning one like first thing or
I get up and I go.
yeah?
Yeah. And then I have coffee.
Mm,
Yeah, like whole it's just like get up, go, and then deal with it. I don't like look at my phone. I do bring it with me for emergencies, and that's it. And
nice.
that's done. That's that. So one of them has to be outside. That one is the one that's definitely outside every time. But I mean, I rode today, so that was outside too because the rower's outside. So yeah, cool. Okay, well, guys, in case you don't know who this fellow is, who I'm so familiarly talking with, it's my friend Shawn from Hack My Homestead, who oversaw and made happen, even with the challenge that the electric company issued to us, the solar build at the Holler Homestead. But he's more than just the person who did the solar here. He does solar consults for people. He's been building a whole approach to deciding when and how and what of going off grid that makes sense with your goals, with your budget, and with the current environment around you. So, Shawn, other than that introduction, what would you like to say for yourself?
Actually, that's a great job. That's exactly right. Been a member of the Tennessee GSD crew since its inception, and just getting things done is what we do, right? So, in 2012, I actually bought an off-grid property, moved my family out there, and designed and installed our own solar system. As a matter of fact, initially it was just batteries and a generator, and then we added the solar our first spring that we were there. And yeah, so I did that. I started talking to more people about it. People started asking me to help them with their own systems that they were wanting to do, and I found that I was doing that enough to where I needed to really turn that into an actual side hustle. And as we were talking about right before we went live, as of, let's just say, 4th of July this year, it will be full-time job. So yeah, excited about doing that and growing that piece of the I guess moving from side hustle to main hustle, I guess would be the best way to say it.
Full time profession, semi-retirement.
Yeah, yeah, something like that.
Yeah, I've never seen you not work all the time. I don't know how that's going to go. Anyway, I think it's really cool that you're making that leap. A lot of people ask all the time, who do I talk to about solar? Blah, 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 blah. And I'm like, you talk to Shawn because he comes in and says, hey, let's look at your property. What are your goals? And then you measure how much power people use. And then you have the get real conversation.
Exactly.
And the get real conversation is, do you really need to be using all of the power you're using? Because scaling your solar we can do it. We can scale the solar to your peak power use. But if you can push down on some of those things, then you don't have to spend quite as much money. And
Exactly.
It costs more money to have a bigger system. So can you talk a little bit about like what led you to take that approach?
Well, it's because that was the approach that I had to take. And when I started talking to people about what their goals were, it became very obvious that there was a disconnect between where they wanted to end up and what they were capable of doing. And so, as part of that conversation, so when we moved off grid, I bought a little meter called a kilowatt meter that I could plug my individual appliances to. And I literally plugged every single appliance that I owned in, and I figured out what it used per hour that it was on. And so the first step for us was, okay, we're getting rid of all the stuff that we don't need. When we make coffee at the off-grid homestead, we hand grind it, and then we use a French press, and we use propane to heat the water or the wood burning stove, depending on what time of year it is, because the little hot plate on the bottom of our drip coffee maker was a significant power draw. And so for us, we couldn't go in and put a big system in. And most people aren't sitting there with a $30,000 budget to just say, hey, I'm ready to go. I'm ready to put in a 15,000 watt solar system with batteries and all this and that. And so those are the people that I were talking to. And so it kind of, their needs forced me to draw on my own experience to say, okay, let's focus on getting rid of the energy vampires. Let's focus on replacing one thing with something else that's more energy efficient. Let's potentially look at breaking this energy independence into small bite-sized pieces and implementing them over time like you're doing up at Holler. And it's way easier to do a $30,000 system when you're doing it $3,000 at a time.
Yeah. Yeah. So it's exactly, we'll talk about that. So I met you in 2017 at Jack Spirko's.
That's right.
And for the first time in my life, because I was really interested in solar, I wanted a chicken door that opened itself and all this other stuff. And you did a solar presentation there, and you weren't even like prepared. You were not on the agenda, I don't think. I think you filled in for somebody, and you just like, bloop, here's how you make solar understandable. And I was like, holy cow, I've been trying to understand this for like 2 years. And I finally understood it. And I remember talking to you, and you said you'd come do an audit here. Do you remember when you came here that first time?
Oh, yeah.
Like tell people what you discovered here.
Well, I discovered that you use a ton of electricity in the summer. That is absolutely your peak period.
Yep.
And of course, we found out later that was because your house was always super humid because you were basically connected to a water pipe. You were built into, the ground there. And so, that was the first thing. It was like, okay, wow, there's a lot of little things that can be done. So that was good. But I do remember thinking like your annual usage wasn't huge, but in the summer you were just way up there.
I was cranking. Yeah. Like I had 4 window units going, and one of them's like a really big whole house window unit.
Right.
And even then I couldn't keep up. It's so funny because this year, so here we are in June, the oven has turned on, right? And my tomato wall is about 2 feet up the windows blocking the sun at this point. So it's starting to do its job. I don't have any AC on right now. And I do have it on intermittently right now, like especially at nighttime, because I like to sleep cool.
Mm-hmm.
But like I'll get up and it'll be 64 degrees outside, and I've actually got new windows, so I can open windows and get a breeze through. And then I'll just shut everything down tight. I have the curtains closed on the south side, so we're not getting sun into the house at all. And it'll be afternoon before I turn the AC on that it's even come up to where I'm worried about it.
Right.
And that is very different than other years. Now, we've had a couple days where I've cranked it because it's been hot. It's been in the 90s, but it's the house itself is holding cool better as of fixing the water underneath problem.
Right.
Yeah. So that's been great. So do you remember what our first project was here to pull me off grid?
The first project, if I remember correctly, was rocket mass heater in your pump house so that you didn't have to run electrical heat tape down there all the time. I think was electrical heat tape you were running?
No, it was actually electric heaters because the heat tape didn't do it.
Okay, the plug-in heaters, right?
Yeah, like I was blowing hot air in the air. That's what I was doing down there.
Right. Yeah. So am I right on that? That was what I was thinking.
That was our second project, but that was a project.
What was the first one?
The solar water heater.
Oh, was that okay? It was.
I think it was first. Yeah.
We'll go with that.
Okay. So I just got my propane bill for the year.
I'm sorry?
My propane bill for the year is $400.
Nice. What was it before?
$750 to $850.
And that was at the old cheaper propane rates as well.
Yep. Yeah. And that was all water heating because I wasn't heating any. I mean, I guess the other thing I'm much better about now is I hang dry my clothes most of the time. So I don't use the gas dryer much. But yeah, everything else, nothing's changed. Usage has not changed. I use all the hot water I want to use whenever I want to use it. It takes 1:45 seconds for the hot water to get from the hot water to my outdoor shower. And I run it till I don't get in the cold shower usually. So, yeah.
Yeah, so and solar thermal is one of those things where the payback is so quick. It doesn't matter whether you're using propane or an electric water heater. Going with, and the way that we did your system, where it's a thermal collector with a circulator pump, and we used your old water heater as a reservoir that now feeds the on-demand heater. That if you have the components to do that, that's a great way of doing it, because you can use one or the other or both in conjunction.
So it was $400 in parts to make the solar water heater, and that's because I opted for copper in a year when metal was really high. It's higher now, I'm sure, but at the time it felt high.
Mm-hmm.
And I also then spent probably a total of $1,000 on an on-demand heater that didn't. So there's two kinds: ones that measure the temperature and bring it up to a digital temperature, and ones that just add, I don't know, 50 degrees or whatever to the water.
Yep.
Or 40 degrees. I got the former kind, which is more expensive, and I needed help getting it properly installed and properly vented because it's propane generated. So, all in, it was about $1,400, and I'm saving $250 to $300 a year in propane. Just for the hot water.
Right.
So that's paid for itself at this point. And if I hadn't put the on-demand, it still would have reduced my hot water gas usage for heating water by $250. Because
Right.
I was using it one summer, I was using it exclusively because we didn't have gas to the house for a few weeks.
Mm-hmm.
And it was hot enough water.
Right.
Straight off the roof between the hours of 10 a.m. and about 5 p.m. here.
You're getting hot water all day.
In the summer, like in July. Yeah.
Sure.
Yeah. So, and even at night, it doesn't really, as long as you don't circulate it at night, it doesn't cool down.
Right.
So like the thing I did is I added a timer to the system so that when the sun goes down, it stops.
Nice. So you're keeping the warm water, which at that point is warmer than the outside air, and you're not getting the direct radiant from the sun. So now you're storing it overnight in that insulated tank. Yep.
Yeah, probably right now the timer's not on there because Tactical turned it on this year, and I haven't gone out to check, so I probably have to add the timer. But I usually, that's fine. Yeah. Okay, so let's go to if somebody wants to do the solar electricity thing, what do they need to do first?
Well, I guess the first thing they need to figure out is if they want to do a grid tied system or not, because the grid tied system has a different set of requirements. And if you're going to do a grid tied system, you also need to look at, am I going to be exporting energy to the grid, or am I just going to be using the grid as a backup for the rest of the system? So those two things will change the kind of the central component, which is the inverter. If you're off grid, you'll have one. If you're grid tied backup, you'll have one. And if you're exporting power to the grid, you'll have another one. Mm-hmm. And so that's kind of the first decision that's got to be made. And then from there, you've got to figure out, okay, where am I putting these panels? Am I going to do roof mount? Am I going to do ground mount? Do I need to split the array up to address shading issues? So if I've got one side of the house that's shaded for half of the day and I'm going to put solar panels there, I want to have a separate array. They're all there together, but they're two different strings so that you're not impacting the one that's not getting shaded during the time of the day that it is getting shaded. And then, of course, the next one is you got to set your budget. Is this a process of I want to replace all of my energy generation or usage with solar generation? Or is this, I have a very specific use case that I'm putting the system in for? And I've done systems this year where people said, I want to do as much as I can for this amount of money. And I'm willing to use used panels. I'm willing to use repurposed things. And so I've designed, systems for people where it's, okay, we want to do as much as we can for $4,000 and I'm okay with using used panels. Well, here you go. And then later, if you want to expand, here's the things you would need to expand that system.
Mm-hmm. And I think that's a really nice approach. A lot of people have gotten into the solar, on the solar train, because they're worried about grid stability.
Mm-hmm.
And I think that's a different a different reason to add solar other than monetarily, right?
Right.
So I know you took advantage of tax credits, I believe, in one of your houses a while ago, and you tapped back into the grid, right?
Yep,
You
that's right.
fed back in. How did you make that decision versus going completely off grid?
So that the system that we wanted to do there, that was a budget driven system. I knew how much I wanted to spend. I was actually doing a workshop around the install. And so I kind of had, all right, I want to stay within this budget. I have this amount of space to work in. I knew I was going to do a ground mount system. And then the other thing that was nice was in the county that I was in Tennessee, I was actually able to find an electrical company that would come out and just do the AC side, which was about 6 feet of wire, which that part is the only part that's actually required to be done by a licensed electrician. And so finding that resource of that person that could come and do that made it really easy for me to go with the decision of, okay, we're going to do a grid tied system. We're going to sell power back to the grid essentially. And at the time, Tennessee had a program called the Green Power Providers Program. And so they would actually pay, a certain rate. Now it's basically net metering. So they've changed it up a little bit. But I wanted to get that system in. And actually I got that system in 3 months before that program ended for the state of Tennessee. So all of those reasons kind of together drove us towards doing the grid tied system out there. It was never meant to be a big resilience thing. It was never meant to be. It was more kind of like a demonstration site.
It was a demo site, and there was a budgetary reason to do it too, right?
Right.
And you got it done because I think so. Let's go through the there are 3 ways, right? You pour back into the grid, you go completely off grid, or you do something like what I did, which is after it's installed to augment the existing system after the main breaker box. Like, what are the pros and cons of each of the 3 of those?
So the pro of the off-grid system is you're not tying to their grid, so you don't have to follow their rules, right? Now,
right.
I will say that the National Electric Code, most of the stuff in there is safety related, right? But the reality is, and with all the electrical work you've done at your place, I know you've seen like, okay, it's nice to have someone that's a professional come in and do those different things, but it's not that you can't do those things, right? As long as you're following the rules, you don't have to have the special piece of paper that allows you to do things on your own property. So that's one of the nice things I like about the off-grid. And the other thing is about the off-grid is that really forces you to load shift, to do some lifestyle design. You don't have that crutch, so to speak, to fall back on of the grid. Like, okay, well, if we use twice as much energy as we produce today, the grid will support the other side. Mm-hmm. That is one of the pros of the system like you did, which we'll call a grid interactive system. So that system doesn't put any money back onto the grid. What it does is it whatever generation you get over the course of a day, that's you don't have to buy that amount of electricity from the grid, but you also have battery backup. So in the event that there's a storm or something else happening in your area where the grid goes down, now you've got some resilience built in. During the day, you've got this generation from the panels, and overnight, you've got the battery that you can draw from. And so I really like that system. The nice thing about a grid tied system in the traditional sense, where you're actually putting your excess back onto the grid, is it pays itself back faster normally. Mm-hmm. And so that, but if you don't have a battery bank and a special inverter in that type of system, when the grid goes down, your system goes down as well. Right. So that's the big con of a traditional grid tied system is, okay, well, if the grid's down, for the safety of the guys that are out there working on the lines trying to get the power back up, you can't do anything. You can't generate. But with the system like the one that you have, where everything operates behind the meter, your generation essentially becomes avoidance, right? You avoid having to bring that.
I'm an avoidant personality with my solar.
you, your system, you avoid having to import any of that energy from the grid. The other nice thing about your specific inverter is you can actually program it to use the battery down to a certain place and then use the grid to either top it back up or to just keep it at that level. So you could say, okay, well, I never want that battery to go below 20% depth of discharge because if it's down to 50% and then we have a thunderstorm and the power lines get knocked out, well, now I only have 50% of the capacity until the sun comes back up tomorrow. So there is the ability to get kind of strategic with the system. And the other reason why that makes a lot of sense is if you're generating more during the daytime hours than you're using during those same hours, and you're not putting the power back on the grid, you're losing that production. But if you're drawing your batteries down to a certain point overnight, now I'm using that extra production just to get, so I'm load shifting. I'm using generation during the sunny part of the day, reserving it in the battery so that I can use it in the evenings when it's not sunny, knowing that the sun's going to come out tomorrow.
The sun will come out tomorrow. I just couldn't resist that. You just,
Hey,
my entire world.
You get it.
It's a musical. My life is a musical.
Right.
Yeah. So, and you made it so I could plug a generator in too and charge the batteries that way. If, for example, grid goes down, it's snowy and crappy out, and the sun's not there to generate much, I can also top off the batteries with my generator and then use those to power what powers there. Now, in order to get this done, we had to move circuits to a sub panel of the things we want to power, and we left some things off. And the two things we left off was the electric stove and the electric water heater. Why would we do that, Shawn?
Well, those are significant draws. And when you've got one battery like you have, you want to minimize the amount of draw that you're pulling out from an amperage standpoint. Okay. If you had 4 batteries, we might say, hey, let's go ahead and just put them all on there. And, if it will just, we've got the pass through grid. But in that scenario, we don't want to be pulling out more than about 4,000 watts at one time from your battery bank. And so if your hot water heater is on, the element is on, and your stove is on, and anything else kicks on in your house, whether it be a light, a fan, the internet, the Wi-Fi router, any of that stuff, be over 4,000 watts, right?
Yeah.
And so it's not that it can't take it. It's just you really don't want to do that if you want to get 15, 16, 20 years of life out of that battery.
Yeah. And we left the refrigerator on it. Just because, we cannot open the fridge a lot if that happens, and it's nice to have your food preserved.
Right. So with you guys, with the cabin, outside of those 2 loads, those 2 big loads, it'll run everything. Now, will it run everything at one time? Can you have all your lights on and the air conditioner and the compressor on? Actually, it probably will. But you're going
to the well pumps on there too.
And the well pump, right. But you're going to be straining the battery at that point.
Yeah, right. So, and I think that's important to know about this system. Like, we sized it partially based on what we needed to get the cabin done, knowing 2 things. One, there's going to be a solar water heater put on that cabin at some point paired with a gas on demand. That's like just going to happen. And we're probably going to install a propane stove in there at some point. So those 2 things will be covered with gas long term. And I think then knowing it was like, okay, Shawn, based on that, what's our usage? How much is it going to be? And you gave me a number. And I was like, well, that's more than I'd like to spend, but I'd rather spend all of it now, one time, to get those 2 things handled than spend half of it now and half of it later. And then that just handles in an outage. I still have water up to my house. I don't have any lights up here if the power goes out right now, except for, well, actually I have some light bulbs that are like, the kind that charge in the lamp. So I have a couple lamps I can turn on, but yeah, nothing else electrical is working up here if that happens. And then at least the guest cabin and the water working are, those are two major things for me. So,
and I will say the other thing that made that system design easy is that you guys got one of those meters where you actually clamp onto each circuit in your box. And so I described earlier that I used the kilowatt meter, and that helped me determine all of the different loads and what I wanted to take off grid and what I didn't, what I wanted to replace. You guys actually tested each individual circuit to know these are the circuits that we can move over to the sub panel.
Yeah.
So anyone that's doing a similar type of analysis, trying to determine what exactly they want to do, if they're going to do a grid interactive system, that's a great idea, is test those. I mean, everything that's on that breaker is going to be on that breaker, whether it's in the main panel or in the sub panel. So knowing exactly what you're using on that breaker over the course of 24 hours to a week really informs that decision to where we were able to go in and say, okay, I think it was 9.72 kilowatt hours per day was the sum of all the loads that we were going to be moving over. And, having that granularity really made it easy to know exactly what to move and what to not.
I think you did not get air conditioning in that, though.
Okay. Because you guys weren't running air conditioning yet.
In the winter, yeah. I think we thought about that, as I recall. So, yeah, I actually, so spoiler alert, guys, eventually there's going to be solar added to this house for the same reason, so that when the power goes out, I still am functional. And there's a big argument about what goes on the solar and what doesn't, because I just want everything on the solar. And I don't want to have to change my lifestyle at all. But that's, from a budget again, I can do that, but it's going to be a major price tag. So we're kind of working through that right now. The cool thing, Shawn, is we will already have wired everything into the sub panel before we get to that at this point, because I've been doing so much remodeling. And so it's, we can put the spider thing on that one sub panel and be done with it. It looks like a big spider, like eating your your circuit board when it's on there. Okay, I got a question from 30-day reviews. If you power your router, is there internet access? Kind of off topic, but I really don't know.
Yeah, no, that's actually a really good question. And the answer is yes, as long as the internet service is on in your area. There are some providers who need power to their distribution boxes in order for them to deliver it to your house. So if internet is available, then yes, 100%. So on the off-grid homestead, we have Starlink, and as long as Starlink is up and the router is being powered, then we're good. As a matter of fact, we have a separate small inverter that's just for cameras, outdoor lights, and the router, so that at night I can actually turn the big inverters off and run off the little bitty 375 watt inverter, because I don't need anything with those couple of things until the next morning.
Yeah, that's really cool. You didn't have Starlink last time I was out there.
Correct.
You had the AT&T MiFi, whatever that thing's called.
Yeah. Yeah. Barely.
Yeah. Yes, that sort of. If you stood in this position.
That's exactly right.
And I think that's something that's interesting when we talk about going off grid. Everybody immediately thinks solar panels or solar power generation, which is a big thing. But if you listen to what we've talked about here, we heated water with the sun without converting it to electricity first, because that's horribly inefficient to do it that way. I just put water on my roof and the sun hits it and it's warm, right? Mm-hmm. And then I follow it with gas, which is, cool. I know people who run pipes around their wood stoves to heat water in the winter. Like that could be my alternative if I ever went that route. Or I could I'm going to Paul Wheaton's PTJ in July, and I'll get to see some of his water heating solutions with the Rocket Mass devices.
Water boiler. Yeah.
Totally interested in checking that stuff out. I can't wait. In fact, guys, if you're going to go, it is buy one, get one for those tickets right now, and I have a link I'll throw in the show notes. I get credit for that, and then he knows I referred you, which makes him like me more and want to continue to sponsor my show. So anyway, use my link.
Are Ernie and Erica going to be there?
I don't know.
Okay, because their book is the one that I read in order to, design and install your deal, and I know they've done a ton of stuff.
Yeah,
with Paul. So
I just know
I sent pictures of your system, and if they are there, like they could troubleshoot. And if you do this or that or whatever.
Yeah. We're gonna end up rebuilding that whole thing, Shawn, because I'm pretty sure we're rebuilding the whole pump house.
Fun.
Ultimately, I think that's going to be in process, because one of the things about the pump house is it also has a lot of air gaps, and you don't have to heat as much if you're well insulated. So, but that's more of a long-term thing. Okay, but we've talked about that. We also, if you look at how, so the way I've approached how I do things here, from a just household living standpoint, I dry my clothes on a rack with the sun whenever I can. And now that Taj Mahal is here, even when it's raining, I can hang them out, unless if the humidity is too high, then they don't dry. And I'll dry them for a day, for about 24 hours, and then I'll put them in for 10 minutes in the gas-fired dryer. I have a gas-fired dryer, not an electrical dryer, so that uses less electricity. And I cook with gas. And I heat water with gas when I'm not heating with the sun. So all of those things reduce the power I use. So literally what I'm using power for is that overhead ceiling fan that basically never gets turned off ever in its history, unless I'm gone, the air conditioning, and the refrigeration. Those things are what pull the most. And then my roasting shack is on a totally different service, and there's no plan to make that off grid.
Right.
Because it pulls 70 amps.
Whew.
Yeah, it pulls power. But my bill is only $50 a month on that thing, like for the business. So, but yeah, the guys, so when the the electric company was here, the transformer was not big enough to accommodate that plus my house. And I said, well, I'm calling you guys to let you know the long-term plan electricity wise. And I think we need to upgrade the transformer. And this is what we're doing in the next 5 years. And I pull 70 amps, and they're like, no, you don't. And I'm like, I do. And so they had their tester on, and they're like, okay, turn on your roaster, lady. And I did. And they're like, it does pull 70. Like, they were shocked, because apparently you don't, like, even in your house, you don't usually pull that much for the whole house. But
yeah, a lot of people so that's 16,800 watts. So a lot of, well, maybe not quite that much, because you're not really getting 240. But it's 14,000. It's every bit of 14,000 watts. So a lot of people get confused when they're asking me to do a whole house design, because they'll say things like, well, I want 200 amp service, right? Because that's what they're used to seeing. And then when we go through their actual list of appliances, I'm like, you probably will never use more than 40 amps at one time. And that's if on the off chance that all of your freezers and refrigerators, compressors come on at the same time while you're taking a bath and drying your clothes. You know?
And running the vacuum.
Yeah. So again, we talked earlier about the National Electric Code. So a lot of those things in terms of sizing the breakers, sizing the individual breakers for each circuit, those are driven by code, not because, oh yeah, I need 200 amps at 240 volts coming into the house.
Right.
It's like, no, you're, unless you're roasting coffee in a massive commercial coffee roaster, you are probably not using that much. So yeah, I can understand why those guys are like, there's no way. And then, but I also understand why you actually are doing that.
Yeah, it was pretty funny. It was just funny hearing them talk to each other, because the reason they were there is when I turned my roaster off, all the lights in my house dimmed, and they were on separate services, and that should not happen.
Right.
And my roast wasn't getting up hot enough. So, it was because I wasn't getting the power I needed, which was not great for the roaster. So anyway, so can you just describe what the build is that we put in for the spring workshop and why it's cooler than the bee's knees?
Yeah, absolutely. So we'll start on the roof. You have 10 460 watt Blue Sun bifacial solar panels. And bifacial means that they can generate from the front or the back. Now, the reality is that mounted on the roof, they're not going to get very much generation on the back side. But if you can imagine your solar panel, I'm trying to get my hand into the camera the right way. So if you can imagine your solar panel and the sun's coming in like this, it can actually bounce off of your roof and bounce back up and hit the bottom of your panel. So you get the direct sunlight onto the panel, and then you get the angle bouncing off the roof. So is it a ton? No. Is it more than zero? Yes. And so you've got all 10 of those panels wired into a single string, and those are wired in series. And what series means is that we're wiring the positive to the negative, positive to negative, positive to negative. And what that allows us to do is increase the voltage of the string. When we increase the voltage of the string, it reduces the amperage, because watts is always equal to amps times volts. So for that 4,600 watts of generation, we're generating that at, call it 400, let's just for math purposes, 46 volts, okay? Which means we only need to push 10 amps. So that 10 gauge wire, people are like, wait, there's 4,600 watts coming through there? Yeah, absolutely. Because we've stepped the voltage up, so we can actually put that through just the regular 10 gauge wire. And so that wire runs through your attic, and it comes down into your utility room, where it goes into a spring-loaded disconnect. And what that allows you to do is actually to disconnect the PV input, and it prevents arc flashes. So you turn it, and then it's like, oh, I'm going to break this thing. And then boom, at the very last second, it opens the circuit up for you. So then from there, you're going into a 6,000 watt split phase inverter. So this inverter will put out 6,000 watts all day, every day. Under load, it will actually go up to 12,000. So it'll put 12,000 watts out for 1 second before it says, okay, there's a problem here. But that's interesting, because most off-grid or grid interactive inverters are coming in, they're outputting 120. So this actually puts out 2 hot legs of 120, so that you can wire into that sub panel just like you're coming in from the street. That inverter is tied to a 5,120 watt hour lithium iron phosphate battery. It's 48 volts nominal. So the system is essentially based on 48 volts. And some people might say, well, why would you go with 48 versus 24 or 12? Well, it's the same reason that we wire the panels in series, because we want higher voltages so that we can get more wattage through there without the amps going super high. Okay. Your battery cables are 2-aught battery cables. So, yeah, they're huge. They are.
I learned all about that once at the electrical store.
If you think about the battery cable that's in your car, those are typically 4-gauge battery cables. And so the way the system works is, the higher the number, the smaller the diameter. Okay. So 4-gauge would be thicker than 6-gauge. 2-gauge would be thicker than 4. And then you've got 0-gauge, and then you've got double zero, quadruple zero, and that's referred to as 1-aught, 2-aught, 3-aught, 4-aught. Okay. So you've got 2-aught cable in there. And again, that allows you to, when that well pump kicks on, you've got what's called a locked rotor amperage, which means that first surge of power to go from the rotor not turning to when it starts to turn is pretty high. And so you want to be able to supply that voltage through the lines very quickly. So that's why we use the thick cables. So that you got the one battery, and then your inverter can take AC input as well as obviously the AC output. Yeah. And so through your AC input, we are coming from the main panel, going through a transfer switch, that you can plug your generator directly to. So you've got your input that's coming in from the main panel. In the event that the grid is down in your area, you can switch the transfer switch from the main panel over to the plug your generator in, crank the generator. Now the generator can both run everything on the sub panel and charge your battery up at the same time.
Yep.
So those all-in-one inverters are a pretty new thing. Like just the last couple of years, have you been able to put everything into one box? You used to have an inverter charger and then a separate charge controller. And so there was no interaction of the PV directly to the inverter, but the system that you have has that. And it's a low frequency transformer in there, which means it's very heavy.
It weighs about 4,000 pounds, as I recall.
Yeah.
We did a video about it. It was like,
yes, it was very heavy.
It was very, very heavy, but it's very cool. We taxed it pretty badly at the workshop because my pump house was not properly grounded, and so it kept shutting itself off to not let a problem happen to itself, which was like, it was that smart, which was pretty cool. But it was running the lights. We finally just disconnected the well pump and ran the lights for the event, and I had karaoke on a generator for that because karaoke was way far away from I was like, we're not running 200 feet of electrical like extension cords to run karaoke. We're just going to pop up the generator for that. But yeah, so the show must go on. So Justin wants to know, besides major appliances, is there anything else you should not run on solar, like a microwave, for example?
So you can run a microwave. I mean, that's it's a big draw, but it's typically a very short duration. When you're using flooded lead acid batteries, which is kind of the older style, most of your old generators, or rather off-grid systems, use the same kind of batteries that are in your car, right? Those batteries, the faster you discharge them, the less they can actually put out. So if I've got, let's say, 1,000 watt hours of stored energy in a flooded lead acid battery, if I draw that power out very slowly, I can get the whole 1,000 watts. If I draw it out at, let's just say I'm drawing it at 10 amps, then I might only get 800 watt hours out. And if I go to 40 amps, I might only get 100 watt hours out. Lithium iron phosphate does not have that same problem. So I would tell someone that is running off of flooded lead acid batteries, you probably don't want to use a microwave. We didn't have one in the off-grid homestead. We used pots on the stove or sometimes the sun to heat things up. But if you have a lithium iron phosphate battery, then it's okay to have that peak draw. You don't get penalized. The battery chemistry allows for both the charging and the discharging to be very efficient, which is why they're used in electric vehicles. And so, yeah, I wouldn't tell someone you can't run a microwave if they've got a lithium iron phosphate battery.
Yeah. And when did that technology really become affordable?
About 2019. So
yeah.
Every year I would look at all the different battery technologies as I'm doing designs for people to determine whether you should do, the flooded lead acid or lithium iron phosphate, or if there's something else that's come out that's affordable. People talk to me about iron Edison batteries, and iron Edison batteries will have about twice the life of a lithium iron phosphate battery, but they cost about 8 times as much. So whereas a lithium iron phosphate battery, it costs about 5 times as much as a flooded lead acid system of the same size, but you can only use half the power in the flooded lead acid system, right?
So
and it lasts 10 times as long. So when you look at it at a cost per cycle standpoint, nothing beats lithium iron phosphate. And so 2019 was when that changed, and it's really just gotten better over the last 3 years because flooded lead acid batteries have gotten way more expensive. And as a matter of fact, in 2020, there was a time when you couldn't find them. You couldn't get the deep cycle ones. It was a 6-month lead time.
Yeah. The 2020 was hard on all of us. I don't understand this question. For a small travel trailer, would it be better to have batteries seriesed or the other way? When not on shore power, everything is 12 volt.
If everything is 12 volts, then you want your battery bank to be 12 volts. So in that scenario, you would probably wire your batteries in parallel. So your 12 volt batteries, you would have all the negatives wired together. You would have all the positives wired together so that the battery bank is still 12 volts, but it gives you higher amperage capacity.
Okay. Luckily, you understood that question.
Yeah.
I was like, I'm just going to say the words and hope. Well, how do people like connect with you / are you working on any interesting projects that we should know about?
Yes. Funny you should ask. So I've got the website hackmyhomestead.com. You can email me, Shawn, SHAWN at hackmyhomestead.com. I do, like Nicole mentioned earlier, I do design consultations for people, and I do the soup to nuts. You give me a list of appliances and or a power bill, and I design everything, help you source the components, and give you technical advice while you're putting the system in. And then I also do kind of like a by the hour thing. So sometimes people will call me and say, hey, I've got this $40,000 quote for this company to come in and put solar. I'd like you to step through it with me, make sure I understand what I'm looking at, what I'm buying. Is this a good deal? What questions should I be asking? So that's another thing that I do for people. In terms of projects, this Friday, I am launching a Kickstarter that will be entitled Solar Water Pumping. And what we're doing is I'm calling it a documentary. I don't know if that's the right word for it, but here's what we're going to do.
An infomentary?
Yeah, right. We are going to build test stands, and we are going to test a bunch of different DC pumps, both submersible pumps and jet pumps, with just a solar panel, a linear current booster or controller, and the pump itself. Mm-hmm. And so we're going to test different configurations of linear current boosters, different solar panels, and different pumps. We're going to test up to like 500 feet of head. So we're going to build a test stand where we can simulate pumping water up 500 feet so we can get what the flow is for each one of those pumps. The other thing that's going to be good for is helping us understand if I've got a pump that's supposed to start working at 96 watts, for example, at exactly 96 watts, what am I getting if I'm pumping up 100 feet, 200 feet, 300, 400, 500 feet? And then the other thing we're going to do is we're going to pump long distance. So we're going to I want to try to have about 1,000 feet of hose, and we're going to pump through 100 and 200 and 300, 400, 500, up to 1,000. And so we're going to show you how to test all this stuff, kind of document the process. Then we're going to provide all of the testing results. We're going to go through how to figure out what your actual total dynamic head is when you're designing your own system. So you've got distance, you've got pipe diameter, you've got how long of pipe it is, you've got your, the pump itself, what it's capable of doing. And then we'll be able to say, and then if you want 30 PSI, this is what you're going to do. If you want 50 PSI, if you're going to put it on a float switch or if you're going to put it on a pressure switch, so basically it's going to cost $3,500 to buy the things that I don't already have, and to the cost to distribute the end product, right? And so that's our funding goal. If we go past that, what we'll do is we'll start adding some other things, like we'll add a booster pump. And so maybe someone wants to look at, I've got a sheep pasture that's like a mile away, and I want to put water in a tank in that area and then pump it up to an upper elevation, for example. And so we're going to go through how you pick the right pump. There's pump systems on the market right now that are $8,000, and the components in that system do not cost that amount, right? So I think I lost Nicole. Can you still hear me? Wondering what's going on here. It's telling me I'm still in the show, so I'm going to keep talking for now. We'll see if I get a text from Nicole. Oh, are you there?
Yeah, I hope you just kept going. I think my internet just reset itself.
Yeah, I actually just said I think I'm going to keep talking and see if I get a text.
Cool.
So what I was saying when you dropped out was there's systems out there that are being curated and sold for $5, $6, $7,000, and the components that you would need to recreate that exact system are like $1,200. Okay,
Yeah.
and so in addition to understanding how to do all of that design work and pick the right pump and pick the right controller and pick the right panel, we're going to show you how to put all of that stuff together so you could potentially save thousands of dollars on that type of system.
Awesome. Well, that sounds like a really cool thing. Keep me informed, and I'll let everybody know about your Kickstarter when you pre-launch or launch or however that works.
The launch is Friday. I will be sending you a link.
Okay.
And so if anyone wants to get there through, I don't know if you'll have, I guess this will be on YouTube once it's done,
Yeah.
right? So,
Yeah.
you know, if you're watching this live, there's no link, but there will be a link.
Yeah, there will be links, and of course the show notes, because this will turn into an audio podcast as well. So
Right.
Awesome. All right, Shawn. Well, thanks for being on today.
Absolutely. Thanks, Nicole.